So I was just filming a video and I just experienced something that virtually everyone who has lived in a cold environment has experienced. That is, my hands got pretty cold and I put them back in my pocket and I warmed them up, and what did I experience but pretty severe pain. Now, what is this pain? This pain is ischemia-Reperfusion injury. What happens when our extremities are exposed to the cold is we tend to close off blood vessels that lead to those extremities. The idea is that the body acts to preserve the warmth of the core. Of course, internal organs, the heart, the lungs, the liver, are much more important to maintaining life than our digits like fingers. So the body has this response of closing blood vessels that lead to the extremities. Well, what effect is that? Well, without that circulating warm blood, or less of it, what we get is cold. So what is this ischemia-Reperfusion injury? Well, what we said was that if you're experiencing the cold, your blood vessels are going to close off and limit the amount of warm blood going to the digits and the extremities. So that is ischemia. Then, after the body warms up, or your hands warm up, then you start getting a return of blood flow, and that is reperfusion. And what happens when you reperfuse places that were previously ischemic or got less blood flow is that blood flow returns with a lot of oxygen radicals. Now, oxygen radicals, in a little chemistry here, have unpaired electrons, and those unpaired electrons are very active and very reactive. So what they tend to do is to bind to things, and well, when these radicals bind to things, well, they form a bond, and that results in the breaking of another bond. So these oxygen radicals that go flying back to these previously ischemic tissues bind to things in those tissues and break them. That is ischemia-Reperfusion injury. Why am I making a video about it? Well, this ischemia-Reperfusion injury that we all feel in cold environments can help us appreciate what it is like, to a slight degree, to be a person who has sickle cell disease. In sickle cell disease, we see alternate forms of hemoglobin. And this really results from one single mutation in one of the genes for hemoglobin. Now, this results in a hemoglobin molecule that responds a little differently due to lack of oxygen. So when we exercise, we can tend to go into oxygen debt. And in an oxygen debt, what we have is a failure to return as much oxygen to exercising tissues as is being consumed. So we go into oxygen debt. Now, for most of us, we simply recover and we do well. But for a person with sickle cell disease, what will happen, or what can happen, is that the hemoglobin will go into a really strange conformation in which one hemoglobin molecule tucks into another and forms large chains. If you've ever had a tent, you know, there are poles that are often shock corded together, and you stick those one in the other and you get this lengthening tent pole, and that extends the shape of the tent. Well, that is really the same that occurs in the red blood cell. So the red blood cells are the cells that contain all that hemoglobin, and when a person with sickle cell disease goes into oxygen jet, what can happen is we get these altered conformations or altered shapes of hemoglobin. They tuck into one another like individual pieces of a tent pole, and then they extend the membrane and the shape of these red blood cells. Now, red blood cells are normally shaped like a little disc, but in the case of sickle cell disease, they are shaped like, well, a sickle. So we get these curved, elongated, and fragile red blood cells. So, well, how does this relate to ischemia-Reperfusion disease or ischemia-Reperfusion injury? Well, What happens in a case of sickle cell disease when we get this polymerization, so to speak, of these hemoglobins, these extension of the tent poles, we get not only oddly shaped cells, but also very sticky cells. And these oddly shaped and sticky cells tend to accumulate in the very narrow capillary beds. Now, capillary beds are really where the gas exchange occurs. They are very, very narrow. Basically, they fit about one red cell through. So when we get these altered conformations and altered shapes of the red blood cells, what we get are the possibilities of occlusion, the blocking of these capillary beds. So anything downstream or in those capillary beds will tend to be, will tend to become ischemic. They won't get the red blood cells, they won't get the oxygen. Eventually, these blockages will be released, and we get a flow of blood back into the tissues. Now, what we know about ischemia-Reperfusion injury is that with that blood flow that comes soaring back, we get a lot of those oxygen-free radicals. And those free radicals, of course, are going to bind to things, and they bind to one thing, they break others. So you get a lot of injury and a lot of pain coming from the reperfusion. Now, these in people with sickle cell disease are called crises, and apparently are extremely painful. And that's why I started off this video with something that we can all, at least those of us in cold environments, can all relate to, which is our hands burning in great pain as we warm them up. It's pretty painful in the hands, but can you imagine what it must be like for someone with sickle cell disease, where the internal organs, muscles are all experiencing the pain? It must be absolutely excruciating. So think about those people with sickle cell disease. There are various treatments. Nothing's great. There are some therapies even to cure it, but I'm sure those are very expensive. But what we can do is really think about those individuals and the pain that they must be in, and really empathize with them whenever we go out in the cold and don't quite bundle up as we should. So I hope this is helpful. I hope this allows you to appreciate a little better what it must be like for an individual with sickle cell disease. And I'll see you in the next one.